Alright, you should have in front of you lesson 4, or sorry, unit 4, lesson 2 notes. Is there anyone that did not get this? Alright. Keep in mind, we do have a quiz next class over what we're learning today and what we learned last class. So make sure you're paying attention and asking questions if you don't understand.
Today is 19th.
Today is the 20th. Alright, so last class we talked about what it means to be congruent. If I have two shapes that are congruent, that means that they are the same size and the same shape. And so, Cade, what does that mean for us? If two shapes are congruent, Cade, what does that mean? What about the sides as well?
Size and shape and angles are all.
Right, so corresponding angles must be equal, the measure of those, and corresponding sides must be congruent, the measure is the same. So it's the same size and the same shape. So last class we knew that if all those pieces were the same, then the shapes were congruent. Specifically looking at triangles, if I knew that every single corresponding piece was the same, then I could say these triangles are congruent. Well, that's a lot of work to show that all 6 pieces, all 3 angles, and all 3 sides are the same. So today we're going to look at ways to prove that triangles are congruent, where I don't tell you they're congruent, but you have to prove that it's congruent. And instead of having to show all 6 pieces congruent, we actually have 5 different little shortcuts here. So, our first shortcut is going to be, let's start with angle side angle, ASA. And yes, you're going to use these abbreviations. So A stands for angle, and S stands for size. So angle side angle. What this means is that for 2 triangles, I have corresponding angles congruent, another corresponding angle congruent, and the side that's in between them is also congruent. So it must be 2 angles and the side in between them. So let's see if we can find one of those down below. Number 2. So number 2 here, I have side SR is congruent to side ZW. Angle R is congruent to angle W. And side RT is congruent to side XW. So again, oh wait. No, I just told you another one. Okay, what's this one? Side angle side. Side angle side. I'm upset. Okay. So number 2 is side angle side. We'll come back to that. Okay, which one is angle side angle? Number 3. Okay, number 3. We need to draw an additional line here. T is supposed to have 2 lines. My apologies for not getting that fixed before I got it. Alright, so number 3, we have that angle R is congruent to angle J. Side RT is congruent to side LJ. And angle T is congruent to angle L. So we have an angle, side angle, angle, side angle. Since they both have the same corresponding angle, side angles being congruent, then by the angle, side angle, we can say that these 2 triangles are congruent. Now remember, it's very important you have it in the proper order. The corresponding angles need to be together, the corresponding letters. So which angle does angle R match up with? J. So this is triangle RST. So we have then triangle JLK. Right. Nope. JKL. Alright, so again, R and J are together because it's the same angle congruency there. L and T go together because it's the same double angle there. And so thus K and S must also be congruent. So by the angle side angle method, we have just stated that these two triangles are congruent, meaning that S and K are the same. And RS is going to be the same as JK, so on and so forth. So your letters must be in the proper order. Now you could have labeled this triangle, the first one, as STR, but that means that these letters would have changed as well. It would have been KLJ. So you might have a different order than your neighbor, but the letters should correspond the same. R and J correspond together, S and K correspond together, and L and T correspond together. Okay. Questions on that? All right, so then let's go back up to number 2. Side, angle, side. Okay, we already talked about side SR, CW, angle R, angle W, side RT, side XW. So for angle RST, what's my triangle over here? Good, WZX. So for triangle RST, WZX. You'll notice too that RS should correspond with WZ. And we see that side RS is congruent to side WZ. Okay, so the sides should match up as well as the angles. Okay, so taking a look then, now you kind of see where we're going. What other methods do you think we have? What do you think might be another one? RA. I heard a lot of gibberish from Nova. Side, side, side. Side, side, side is indeed another one. Which number below corresponds with that or goes with that? Number 1. We have side AC goes with DX, side CB goes with XK, and side AB goes with DX. Okay, so this is by side, side, side. Triangle ABC goes with what? Triangle DKX. Make sure you take that extra second or two to slowly go through and make sure your letters correspond. Side AB should correspond with side DK. AB, DK. Those are the same. Alright. Now, I'm going to do the last two together. Taking a look at what we have down here, do you have an idea as to what one of them might be? We see we do have 2 angles and a side. And down here, we actually have an angle and 2 sides. But I'm going to tell you why that one doesn't work. Alright, so number 4. We have angle, angle, side. That is another way. Angle, angle, side. Alright, so we'll take a look down there. Angle Z corresponds with angle R. Angle P corresponds with angle T. And side MP corresponds with side TW. Alright, so this is by angle, angle, side. So we have triangle MZP corresponds with what triangle? WRT.
Wait, why is this like, okay, so SKS and ASS are the same as
So Kate asked a great question there. There's a reason why we're going this particular order. We are using the same 2 letters and different combinations. So you may be tempted to think that these 2 are the same because we have 2 angles and a side, but the placement is important. Here we have 2 angles and the side in between them, whereas here we have angle, angle, and a side next to it. So it goes in that order. So make sure you're not trying to do, like for number 3 here, this is not angle, angle, side. Don't be skipping sides and angles within it. Notice, in order to get from R to T, going that way, I would have skipped this side, and this angle, and this side. You can't be skipping that much in between. So it's side, or it's angle, side, angle. The side is between the 2 angles, whereas down here, I have angle, angle, side. So that order is important. Now, granted, side angle angle is the same thing as angle angle side. Just like angle side angle, same thing as angle side angle. But these two are different. That order matters. Does that make more sense? Okay. So now let's take a look at our last one. If we were looking at our letter combinations so far, you might think that this last one would be side-side angle. Alright, so you would think, okay, well probably side-side angle would be it. Now I want everyone to be quiet and not say anything for 10 seconds. If we read this the other way, it would be a bad word. We don't use such words in mathematics. Such foul language is not okay. This method does not work. Such things are not okay in math class. So that is how you're going to remember that this is not allowed. This is not a method. And genuinely, this is not a method to be used. So that's how you know, don't use this.
Why not?
It's not okay.
No, but like why?
So what our last one is actually HL.
This paragraph. I can't remember that.
Alright, let's take a look at our last example. What type of triangle is this? It's a right triangle. And we have the method HL. Anybody have an idea what those might stand for? Hypotenuse leg. So our HL method only works for right triangles. This is only for right triangles. So hypotenuse leg only works for right triangles. If it's not a right triangle, it doesn't even have a hypotenuse. So only right triangles, H stands for the hypotenuse, and L stands for the leg. What's that? So sometimes that works for another one. Let's take a look at number 4. So number 4, we have the hypotenuse, but not a leg. So just because it's a right triangle doesn't mean you have to use HL, but HL can only be used on right triangles. Alright, so my last one here, it is a right triangle for both of them. They each have a leg, and their hypotenuses side are the same. So this is HL, the hypotenuse leg. Alright, so VMT corresponds to, or is congruent to which triangle? Close. I heard someone say C. Notice how we go V to M, so we want side 2. C, A, B. And again, double check to make sure that what order you just said works. MT should match up with AB based upon what we said. MT, AB, that's my remaining side. So by the hypotenuse leg theorem here, we have that these two triangles are congruent, meaning that each piece is congruent. All right, questions on that? Thank you. Okay, questions so far in those 5 ways? Okay, so remember CP, CTC, congruent parts of, or corresponding parts of congruent triangles are congruent. So once I've stated that these triangles are congruent, then I know that this remaining side is the same. I know that angle T corresponds with angle B. I know that angle B corresponds with angle C. But first I have to state that they're congruent. And my 5 ways of stating they're congruent are these 5 ways. Okay. Alright, let's take a look at the back side.
The next page. We have a lot.
Alright. Now that I know this is a W and not a sideways E, life makes so much more sense. Like, seriously. I'm like, okay, why would they put E with X and Y, and why is it written sideways? I don't know. Alright, so let's take a look at this first one here. Just like we had within our homework 2 class, or the worksheet 1 last class, the classwork, sometimes we don't have triangles by themselves. We have pictures where the triangles are together, they're overlapping, they share a side, and we have to understand those within our triangles here. So my first one here, it shares the side WM, so clearly WM is equal to itself. Reflexive. So I know that these triangles have that same side. That side is the same. So for my first one here, what method would I use? Side, side, side. Alright, and again, be careful with your ordering. T, M, W, X, M, W. Alright, my next one here. What is shared that's going to be the same? AC is the same, so we know this side is shared. They have the same thing there. So what do I have? Angle, angle, side. Again, for this we do not have angle, side, angle. You had to skip a side and an angle within that to get there. You can't be skipping an angle and a side when you're trying to make your acronym here. So angle, angle, side. All right, ABC corresponds with ADC. So you could have started and said BCA. Your other one would have then been DCA. So you can start with the different letter. Just make sure your A and A corresponds, B and D corresponds, and C and C corresponds. When you're trying to decide. So you want to make sure that you're not skipping an angle and a side when you're trying to accomplish it. So like right here, if I tried going around this way, if I started with angle D and try to go to my side, I skip this side and this angle. You don't want to be skipping too many pieces of information. If I go the other way around, I'm allowed to just skip one side or skip one angle. And you'll get the hang of it the more you do this. So here, I'm skipping too much. I need to have one of those pieces. I don't have it, so go the other way around. Angle, angle, side. Alright, our next one. What is shared? MK, our hypotenuse is shared. Yes.
Is there one of the
Great question. So Eric just asked, is there a third thing for angle, angle, angle? Let's suppose I have, let's make this a 30, 60, 90 triangle. Let's say this is
question last class and you did not answer.
a 30, 60, 90 triangle. Alright. Now, I'm going to have the same angles.
Okay, why so large? They're not congruent because just because their angles the same, still have big sides.
Exactly. They're similar triangles, but not congruent triangles. The angles do not limit my side lengths. The side lengths limit your triangle and how big and large you can get. So we actually don't have one that's angle, 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 because they don't necessarily have to be congruent if all angles are the same. Let me give you another example. What are all of the angles within a square? 90 degrees, right? So all of my angles are the same, but it's clearly different sizes. You're right. For squares, we couldn't be. And so what we're doing right now, we're proving triangles congruent. So these 5 ways only work for triangles. You can't use these 5 ways to show that squares are congruent.
What if the angles are the exact same? What if? No, for a triangle. They are.
Yeah, they are.
No, but you have a right triangle. What if it's like 30, 30, 30?
Here we go. Here we go.
1 degree, 1 degree, 1 degree.
Do you have a remaining question now, Kate? Okay, so we do not have angle, 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 because your side links could be different. I'm so glad you asked that, Eric. Alright, let's continue on through. So what do we end up having here? What method can we use? Good, HL. Remember, side angle is not okay in this classroom. Alright, so MQK corresponds with what? Very good. Very good. So notice you might be tempted that since we start with M to start with M again. But notice NQ, that's my short side link that has that congruent leg. So I have to do KN. I have to start with K because that is my short side congruent side. So I actually have to start with K here. And M. So again, make sure you're really careful with these, and it's always good to go back and double check. MQ should correspond with KN. MQ, KN. Okay, now remember, we have not learned anything about parallelograms yet. You may not know this, but prior to last class, you actually did not know that all the degrees in a triangle are 180 degrees. You didn't know that until you learned that last class. So, you don't know anything about parallelograms and the lengths of their sides. All we know is stuff about parallel lines. So what can we say here? If these are my parallel lines, and I have this transversal, alternate interior angles. Oh.
What?
These are my parallel lines. This is my transversal. So alternate interior angles are congruent. So I know those two angles are congruent.
Oh, wow.
Parallel lines are here to stay.
No.
Hey, by the way, this is not a trash can. That is a recycle bin. Okay, so again, if I look at these as my parallel lines, with this as my transversal, then I can say these angles are congruent. Notice you have to go with both sets of parallel lines. Right now, I cannot say this little green angle because it's that whole thing. So you have to use both sets of parallel lines. Okay. So now that we have all of those angles there, we don't have quite enough information. What else do we still need? We need one more thing. What do we need? The middle side here, yeah. They share this. They're equals. We do not have side, side, side. We don't know anything about their sides. We only know this middle side.
Angle side, angle side.
Angle, side, angle.
Wait, why not angle side?
So again, we can't skip too much. If I try to go around this way, I'm skipping my side, my angle, and my side. Angle, side, angle is the side in between two angles. Angle, side is two angles next to each other.
Black coffee.
I don't know why it's funny.
Okay, back to triangles. So, triangle RVF. So E and R go together. And F, good. Again, our little angles here, the two notation angles, means that F comes next. So again, just because the letters are the same doesn't mean they're in the same corresponding locations. So again, side BF should correspond with FB. And side RB should correspond with side EF. RB, EF. Okay, last one. This should be easy. What do we have? And side angle side. WYZ goes with WXZ. Good.
Wait a second.
There's still more.
All right, next side.
What's the first one?
Wait,
You can order
didn't you just say that you're not supposed to
beans.
angle that you started with, like, you're supposed to be wide?
Wait, why are you asking me this?
Sometimes it's in that same corresponding place. You have to be careful. Up here, B was split up into two different angles that were different, like different measures. W it's split into two angles, but they're the same measure, so you use W the same place. Alright, next side. Again, the more practice you have with this, the quicker it comes. You start to get used to what these different methods look like.
That's time I hit the desk.
Alright, I need everyone to scroll down to the third problem.
Eric, I can't answer.
Look down to the third problem. Alright, we're missing some information here. I apologize. I did not get this information in before I copied your notes. So this is information that should be added in. RS is congruent to ST.
Hey.
It looks like Rudolph the Red-Nosed Reindeer upside down, so
No,
it's
it
nose
don't.
up top. Alright, and then the other piece that we are missing is angle Q and angle U.
Oh my goodness.
Alright. Okay. First problem. Again, all this information we've learned so far this year is still applicable. Right now, do we have enough information?
Yes.
Well, we have two sides. But what else do we know? Vertical angles. By the vertical angles theorem, vertical angles are congruent. Alright, so what method can we use? Side angle side. Alright, so we have angle A, or triangle ABF. Again, you could have started with a different letter. And what does this correspond with? C, D, F. Okay. Alright, we're going to move down to the third one. We're going to do the second one, but we're going to move down to the third one. Now, we have a lot happening in this one, so I need you with your A game focusing here. Are you ready?
You made it complicated.
Now we have overlapping triangles. I think it's very helpful to go ahead, when you have this, draw them out. What we have is this triangle, SRU, and then we also have this triangle, STQ.
But you can't do that because you can't have separate.
But we haven't proved they're congruent yet. We're going to. I'm just trying to show you where these two triangles go. Okay. So those are my two triangles. When you have overlapping ones like this, I highly, highly recommend you draw them separately off this side. Pull them apart. Now you were given that SR and ST are congruent, and that angle Q and angle U are congruent. Let's go ahead and draw that off to the side here. Q and U. And then this notation is only for ST. It's not for the entire length SU. So ST is congruent to RS. This is only for that length there. Okay, we only have an angle and a side. Alright, guys.
Uh,
I gave those to you.
three.
Alright, I heard vertical angles, right? We've got some vertical angles.
Sweet.
It forms a bow tie, that's what it is.
I put it to 200%.
I can see it. There's also see it, but I can't see it.
Oh, these are vertical angles.
Supplementary linear pairs.
We could say
Uh,
that these are congruent, but since
You
this
not
isn't
use
part of one of my
yellow.
triangles, we don't
You
need
can
that.
figure out what that angle is.
So, there are how many degrees in a triangle? And if I know two of them have to be the same, what must be true about the third one? I'll say it again.
Oh, I get it now. Hey.
I'll say it again. I'll say it again. Angle Q, angle U was given to us. These two, the red ones, are congruent because they're vertical angles. Vertical angles theorem states that vertical angles are congruent. Now, we have two triangles. They must add up to be 180 degrees within their angles. We know two of them are the same. If you want, I can put numbers to this. Let's say
90.
yeah, let's go with the easy numbers. Let's go with the easy numbers. Let's say these are 30. And let's say that my reds are 60. So how much has to be for these purple ones? They have to be the same.
I was just gonna say they're
That means that the purples are congruent.
Are we good right now? Right now, we need more information. So we're trying to find out what more information we can get. Yes, Chelsea. I gave those to you. It wasn't on your paper, I told you. I'm sorry, it should have been there before I copied your notes. So Q and U are given to you. Yes, Tim.
So like, that.
I know.
Wait, don't go further. I just want to answer questions before we go further. Are there questions before we move on to the mind-blowing stuff? Okay. Now, again, let me highlight the triangles we're doing here.
Don't use yellow, like that really my eye so bad. Use yellow.
I trade love the colors.
No, smart grass.
We need something here. We need more information. What can we do? Liam.
And you bring supplements theorem, and you can get QTS equal to URS.
So we have
I mean, similar supplements.
green. Let's go with green.
Yes, please.
Linear pair. Linear pair. These two are the same. So this 1, 2, 3, 4.
Yeah.
No,
1,
4.
2, 3, 4 must be the same.
No.
So again, linear pairs. Linear pairs. If these are the same, if purple is the same, green must be the same.
It must be the same.
Linear pair means they're adjacent angles that create that straight line. This is a straight line. That's a straight line. So guys, my linear pairs that I just used was this. These are linear pairs.
And then we have angle side.
Those are linear pairs. Which means they're supplementary.
You have to mark S as like the same thing or is only on.
Which thing?
Like after this, can you conclude? Can you say?
Yeah, but I like what you said. We'll throw that in.
What is that?
Okay, so what did we just show here?
That they're the same.
That SRU, angle SRU, is congruent to angle STQ.
Hey, good, right.
What do we have there?
This is our diagram.
Angle.
Diagram.
So we have angle, angle, side, angle, side.
Does geometry
So-
get harder than this?
Geometry just has different pieces. Some pieces are harder for some people, some pieces are easier for some. Alright, so let's do STQ. STQ corresponds or is congruent to what triangle?
SRU.
SRU. Alright, are you guys ready to be mad at me?
Yes! I didn't know this trippy triangle.
I made you do all of this work because I want you to see how we can have hidden information like this. But what could we have said about angle S for each of these? So before we did this information,
We wouldn't say
angle side.
Wait, can you explain that?
So as you see, sometimes. Yeah, so we actually didn't have to go through all of that work because we had angle S is congruent to itself. So we would have had angle side anyways. But I want you to see how you can have hidden information in there. Look at how much we learned. Okay. Now, let's do the second one. The second one, you guys want to do the second one?
yes, go in order, please. It annoys me.
Okay. Now, no, we need to do the bottom one first.
No!
Yeah, let's do the bottom one first. I want to give your brain a break first.
That does not look like a break.
Alright, again, you don't know stuff about parallelograms. You probably don't even know that word yet. I haven't told you
I
that
know
word.
what it is already.
So we have HF is congruent to itself. HF is congruent to itself. Now, again, we have parallel lines. So just like we did before, here are parallel lines. Here's my transversal. So I can say these are congruent. Likewise, actually, let me undo this. Alright, so we just said that these are congruent. Likewise, if we take these as my parallel lines, and this is my transversal, then I have these are congruent by alternate interior angles.
Is this the same thing we just did?
So this is angle, side angle. And let's zoom out some so we can see what's happening.
Yes.
Alright. What triangles do I have here? Alright, we'll go with HIF.
What?
F, G, H. Good. Again, make sure your sides match up. GH should correspond with IF. GH, IF. Alright, let's go to number 2. You gotta be sharp and on your toes for this one.
Worse than the third one?
No! I like third one. Yes, Kate. Distraction? Okay. Alright. What else can we tell right away?
That there's an angle in there.
Vertical angles. Alright, so we have vertical angles here.
Oh, it's another bow tie.
Alright, now we just have a side and vertical angles. Now, let's extend our parallel lines. And it really doesn't matter matter which transversal you use. Because here we get, let me use alternate interior. If we use the other one as my transversal, let me draw it back. I use the other one as my transversal here. Then I have that these are alternate interior. Let me erase.
Yes.
So we have those are alternate interior. Okay. Let's be careful though. What do we think we have? You could go with angle, angle, side, or you could go with angle, side, angle, right? But be careful. If we try using either method, let's say we do angle, angle, side, and I'm going to use this to help us out. If I do angle, side, angle, when we try to do angle, side, angle again, is this angle the same as that angle?
No.
Hey, you got it.
No.
Cardigan.
So sure, we have an angle, side, angle on one triangle, and an angle, side, angle on the other, but it's not the same angles that are corresponding. Blue and red are trying to match up, but blue and red are not the same. Yes, green and green are the same. The side and the side are the same, but blue and red are not the same. And if you try it any other method, like we can try angle, angle, side, but angle, nope.
Wrong way.
Angle, side angle, 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 side, it doesn't work. So these ones end up being not congruent.
Dude, this was a purpose. You made us
yeah.
this one. That makes sense.
So these ones end up being not congruent. Now, anybody have an idea what could have been changed about the picture to make it congruent?
One more congruent sign.
The UM is congruent to MI.
Yes, if it would have been changed to where UM was congruent to MI, and this was not here, then they would be congruent. Because notice now it goes side, angle, side, blue, black, green, blue, black, green. So that would have allowed it to be congruent. Okay? So again, be careful. Make sure that it's the same angle measures that are going together, the same side measures that are going together. Okay? All right. Let's take a look at the next page. Okay, so now it's triangles with insufficient information. Showing you some things that might happen that you would be quick to think, oh yeah, they're congruent, but they're not actually because we don't have enough information. What's wrong with the first one? It's all angle, angle, angle. That's not okay. We don't know anything about the lengths and the sides.
No.
So these, we don't know if they're congruent or not. So we would say not enough info. No info. You don't want to say not congruent because they might be. We just don't have enough information to determine whether or not it is. Alright, so that's my insufficient information there. What about my next one? Why is there not enough information?
You need a what?
Yeah, we only have a right angle and the hypotenuse. We don't have a leg. So we're missing our leg. No leg.
How can it not be congruent if it has
Hmm?
How, like, if it had, like,
It
congruent,
could be.
like, hypotenuse, and how could it not be congruent?
So it could be that these pictures are congruent. We don't know that. We don't have enough information. Because maybe this is 1 inch and this is 1.1 inches.
But then how can the hypotenuse be the same length if, like, they have different side legs?
The legs can be different size.
Because your hypotenuse would come down like this. This leg would also be a different length. Both legs would have to be different lengths than those two. Okay.
I mean, I don't understand.
I can show you a picture if you want me to afterwards.
Just another thing.
Alright. What's wrong over here? This is side angle. That's not allowed in this classroom. But it's not a right angle, so it's not a right triangle, so we can't use it. And what's wrong over here? It doesn't match up. This is side, angle, side. But this is side, angle. Those don't even match up, and this one's not allowed anyways. So, they don't match up. Yes.
Why isn't that?
What is this, backwards?
Oh.
Not okay.
That's good.
You read just like your mom?
It has to be a right angle.
This method does not guarantee congruency. It's possible to have triangles in which a side and angle match up, but they're not congruent. So that only works for right angles, which is why we use H out, because it's only for right angles with the hypotenuse. Alright, questions on this part? Okay. So I want you to now try these bottom ones. State the method used to prove the following triangles are congruent. If it's not possible, say not enough information, or insufficient information, or we need more info. Something like that. Alright, so go ahead and give those a try. Then we'll come back to go in the group. Okay, so let's quickly go over the remaining problems and see what we have here. Remember, your homework is worksheet 3 and worksheet 4. That is due next class on Tuesday, and you do have a quiz next class over what we've learned today and last class. Alright, so number 1 here, we have a side, angle, side. But over here we have side, angle. Those don't even match up. That one's not even allowed, so this one's not enough. We don't know that these are congruent. Alright, number 4. This middle side is the same. So we have angle, angle, side, angle, angle, side. So they are congruent by angle, angle, side. Okay. Next, we have our middle side again is the same. So we have they are congruent by side, side, side. Alright, with our next one here, we have that middle length again is the same. Now, do we have enough information? No, because we only have this one angle on either side. We don't even know if it's right. It kind of looks like it, but we don't know for certain. So not enough information. We only have an angle and a side. They're not even next to each other, so not enough information. Or insufficient information. Alright, next we have side, angle, side, side, angle, side. These match up, our angles match up, and our other sides match up. So this is true by side, angle, side. We can say these triangles are congruent. Alright, our last, or number 8 over here, we have sides match, angle matches, but side, angle is not allowed. That one is not a method that works for us. So this is not enough info. Again, we can't say that they are not congruent, because they might be. We just don't have enough information to show that they are congruent. Alright, then number 3 down here. We have our middle sides are the same. So this length is the same. And we have corresponding angles here, congruent, corresponding angles here, congruent. So angle, angle, side, angle, angle, side. So this is true by angle, angle, side. Alright, number 6. I like this one. So we have to use parallel lines again, what we know about those. Alright, let me zoom in some so we can see what we're doing here. Alright. If I isolate 2 of my parallel lines, let me go ahead and do this here. Whoa, that's really thick. Oh, let's try again. Okay. So here are two my parallel lines. If I use this as my transversal, that's great. I can say by alternate interior angles that these are congruent, but notice that this angle right here is not even one of my triangles. So that's not going to help me out much. Also, I could say that these angles are congruent, but this isn't even in a triangle, and this is more than just that little angle in the triangle. So again, those don't help me out. Alright, so let's change my transversal. So it's off to the side. What if we had a transversal? Say this was my transversal. Back again, let's say that this is my transversal here. Well, I could say a few different things. I could use alternate interior angles, but again, that's going to give me something that's in my triangle and one that's out. Let's try instead corresponding angles. This angle is corresponding to this one, so those two angles must be congruent. And notice both of those are within the triangle. Alright, so now let's try a similar thing with my other set. With my other set of parallel lines. It's not moving. Okay, again, we're going to take a look at these as my parallel lines now. They tell us that those are parallel. We could try using this as my transversal, but again, alternate interior angles is going to give me one angle within and one angle without of it. So that doesn't help me out much. So as you probably guessed, we want to use this bottom line as my transversal again. If we look here, similar to what we just did with that last one, by corresponding angles, I have that these two are congruent. Make sure when you're drawing in your notations like this that you use 1 and 2 arcs, or 1 dash and 2 dashes. Make sure you're differentiating between, because I don't know that all of my angles are the same measure, just that my blue angles are the same and my green angles are the same. Okay, so I have those. Let's move my extra lines out of the way down here. Alright, so then now I see that I have angle, side, angle, angle, side, angle. So I know that these are congruent by angle, side, angle. So we had to do a little bit of work to get to that one. Alright, then our last one down here. They're overlapping, but actually they already gave us all the information we need. We have angle, side, angle, angle, side, angle. So we end up having these are congruent by angle, side, angle. Alright. Again, remember that next class is your quiz over day 1 and day 2, which is today. And worksheet 3 and 4 is your homework that's due next class. Make sure you come see me if you have questions beforehand, and then we'll take the quiz.